Hello everyone, welcome to my channel. So now we are going to do the lead code bi-weekly challenge second question. So let us first read this question. So minimum number of operation to make the array empty. So here we are given zero index array nums consisting of positive integer. There are two types of operation that you can apply on the array any number of times. Choose two elements with equal values and delete from the array. Choose three elements with equal values and delete from the array. We are required to return the minimum number of operations required to make the array empty or -1 if no such operation is possible. So basically, like the thing is that we are required to make the whatever count would be there. So that count we are required to split in such a manner that we are required to do minimum number of operation. So for example, so first let us take for the constraint, then I'll let you know the one more example. So here the constraint is up to 10 raised to power 5. So basically we can't go ahead with n squared solution. We can only go ahead with n log n or n solution, and the elements could go up to 10 raised to power 6. So now in this first which is given to us, so here if we see the count of 2, basically that is 4, right? So we can split this into 2 plus 2. Basically that would be 1 plus 1 pair. This I'm saying about the pair and this I'm saying about the splitting part. And now comes the part for 3. So 1, 2, 3. So here 3 is basically we can split in only one form, right? So basically there would be only means pairing which could be done. You can't say it as pairing, but yeah, basically all the elements when we are combining. So basically that combining we can only do once, because here we if we do 3 modulo 3 then it will become 0, and here if we do 4 modulo 2 it will become 0. And here the thing which is there, that is for the 4, then 4 is already present. This I was saying for 2. This was the count for 2, and 4 is present 2 times, which we can only split one time. Means when we do modulo by 2, then it will be equals to 0. That's why only one pair is possible. As we are required to go ahead with only 2 or 3 elements combined, right? So that's why in that context only we are required to do the pairing. So here if we see here number 2 which is there, its count basically is 1, 2, 3. So its count is 3, right? So basically, as its count is 3, so here either we can take 3 elements combined or 2 elements combined, right? So we can take 3 elements combined, right? So when we do 3 divided by 3, that will become equals to 1. That is, one combination is possible for this particular, right? Now if we see for the count of 1, so one count is 1 only. So if we divide by 2 or we divide by 3, that won't be possible, right? So because of this only we are required to return -1. Basically, if any sort of that count is there, which even if we combine by doing modulo with 3 or doing modulo with 2, we are not able to pair it up with anyone or combine it with any group, then the thing would be that at that moment of time we are required to return -1. So these were straightforward. But if we take example like this, so here if we see, we can directly go ahead with this, right? Or if we take example something like this, here we can either form pair like this, right? So here it is 3 pairs. But if we take it in the form of 3, then here it would be 2 operations, right? So this is the minimum one. And there could be some other cases as well if we take it as 7. So if we take as 7, then this would be the one operation and this would be 2 more operations. Or other possibility we take, that could be like 3 and this as the 3, but here it won't be possible, right? So that's why we are would be required to take this possibility only. So that's why in that scenario, the thing would be that we are required to do operation in such a manner that it is the minimum, the way here the example was, and it is also feasible, the way it was here. So this is how we are required to code our solution. So now let us go ahead for the coding part for the same. I hope it is clear till now that how we are required to make the combinations of the same in such a manner that it is the minimum. Okay, now first part is that let us take the count of whatever elements we are having. So for taking count, I would be taking unordered map here. Any other could also be taken, but I am preferring here with unordered map. So here MP of I plus plus. So here we will be able to get the count. Now after we are good to go with count, so then now I will be going ahead that whatever count was there. So int count equals to I dot second. So it will give us the count of that particular element. Now here comes the part for our main logic. So now first thing which we will be doing, because 3 is that pair, means combining 3 elements together will give us minimum number of operations, right? So in that context, at the starting only we will be checking that if we do modulo by 3, is it equals to 0? If it is equals to 0, then in that context we will be directly doing operation plus c equals to our count divided by 3. Here OP simply refers to the operations, I want to say. Now the next thing which comes into picture is that if that is not the case, then we would be required that we will be checking that if we do count modulo 3, then in that context, what is the one which is now being left? So that we will be checking. So in that context only, I will be going ahead. But the thing is that if we check that if we do count modulo by 3 and its modulo is left out to be as 2, right? That would be one possible combination. But we are required to check one more scenario, and that would be that if we do this thing, is whatever count is there, and from that only, so now here, whatever we will be getting means after we divide by 3, whatever we will be getting, then if we do multiply by 3, right? And then if we subtract that from our count, and then we do modulo by 2. If after doing so, if we get equals to 0, right? So then we can surely go ahead with this combination, means whatever operation we have done till now, in that we will be adding up count by 3 plus this thing which is there, that we will be adding up there. Basically this thing. But here we are not required to do modulo. Here we are just required to do by 2. And the reason for the same is, let me show you one example only. So here this count by 3 simply refers to that whatever the till now whatever the count we were able to get, that we will be going ahead directly. But whatever we in this only, here we were easily able to get by if we do like this, right? So here the answer would be 2 for the same, right? Here it will be 2 and we will be doing by this, means when 7 is the count and if we decrease by 6, right? So here the thing would be that we do this and we won't be getting this, right? So for that scenario, we are required to do some, means we are required to handle the other case. But here the thing is that if we subtract by 6, for this I would be required some other example. But for this other scenario which was there, then for modifying the same, we can just go ahead with this. Since here we will be just taking by subtracting by 3. And if any of these cases is not possible, then we will be directly returning the -1. And at the end, we are required to return itself. So now let me tell you for both of the cases, I have taken those. So now basically this case which is there, it handles this scenario. If we have taken say 7 times, right? So basically if we do something like this. So here the 3 which is the 3 pairing is done 2 times, right? And this is left out, right? So just for doing this, we will be simply decreasing this by 1, so that here we can get pairing of 2 as 2 times, so that our overall answer will become as 3. Earlier it would have been like 2 plus something which is not possible. So that was the thing for this scenario. So that's why what we are doing is, now we are checking that whatever count is there, from that we are subtracting by decreasing it by 3, so that we can decrease this one pairing which was there. And after decreasing by 3, we will be again dividing by 3, right? So when we divide by 3, then we will be getting 1, right? And when we do 1 by 1 into 3, so that thing we will be decreasing from our overall count which is there. And then we will be getting 4. And when we do 4 modulo 2, that will be 0 only, right? So that's why here count minus 3 by 3 we are doing. And then from the count, whatever we did here, that only, and just we from modulo we got it to divide by 2, so that how many pairs are formed, that we can easily get here. Now this was that operation where we can logically form this thing, means basically when we are having say 5, so means count is equals to 5, right? Say the number is this one only. So here you can clearly see that if we divide this 5 by 3, right? So what we are getting? We are simply getting 1, right? So that is the pair. And when we decrease this particular only, means 1 multiply by 3, means when we do 5 minus 3, that will be equals to 2, right? And when we do modulo by 2, that will be equals to this. Basically that will be equals to 0, right? And that is this pair. right? So in that scenario only, so basically in that scenario only, we will be able to get this particular else case passed and we will be getting our answer. And this other case is in that scenario when we are not able to get from this particular. So that's why we are decreasing the count of the three. So at the end, then we will be returning our operation if we are successfully adding up them in either of the case. Else, we will be returning -1 straight away. So let us first run our test case. Means is it able to run in our example test cases? Say here, and then for example test cases, if we run 4 and -1, and if we submit the same, so it get accepted. Now comes the part for the time complexity and space complexity for the same. So basically, here the time complexity, here you can see that it is order of n. Again here it is order of n. Then for all these mathematical operation it is order of 1. Now so basically at the end the time complexity will become order of n and the space complexity here will directly become equals to order of n only because we are taking this unordered map for storing our count. So this was all for this particular question. If you have any doubt, you could comment that down. And if you really like the explanation, if you really like the solution, you can like, subscribe to my channel and do share among your friends as well. So this was all for this video. Thank you.